Hello everyone, welcome back to my channel. My name is Dr. Yogita Bish, and in today's video we will talk about Hund's rule of maximum multiplicity. So this is the fourth video in continuation of my video series called electronic configuration. In the very first part we studied about different type of quantum numbers. There are four set of quantum number. Then in the next part we studied about the Aufbau principle, and in the last part of this series we studied about the Pauli exclusion principle, and today's video we will talk about the Hund's rule of maximum multiplicity. Alright, so let's just begin. And if you have not watched my other videos, I would highly recommend you to watch these videos. Then only you will be able to understand the whole concept properly. So I will provide the link of all the videos down below. Alright, so let's just start with this. So Hund's rule of maximum multiplicity, it deals with the degenerate orbitals. So first we will try to understand the meaning of the degenerate orbitals. So what are degenerate orbitals? These are nothing but the orbitals having same energy. I'll give you an example. You already have the idea about the p orbitals, right? So how does the p orbital look like? Like this, whereas s orbital like this, right? D orbital, it look like 1, 2, 3, 4. Yeah, like this, right? So here you can see three orbital together, right? So these three, this is px, py, pz, they have the same energy, right? So these orbital will be considered as degenerate orbitals. So the orbitals which have the same energy. Similarly, in d orbitals we have 5 degenerate orbitals. They all have the same energy. Whereas in s we have only one orbital, right? So if we have to arrange them in the according to the energy level, if you can recall the Aufbau principle, we had something like this. 1s has a lower energy as compared to the 2s, then 2p and 3s, and so, right? So if we have to arrange this in an energy level diagram, you can easily see that this is 1s, then 2s has a little higher energy, then 2p, and so, right? So if we have to fill the electron need to be filled in first s first, right? 1s first. Why? Because it has a lower energy, and in each orbital we can have maximum 2 electron, that we have also studied in the previous video of the Pauli exclusion principle. So it can have maximum 2 electrons. Then similarly in 2s we can have maximum electron, and then 2p look like something like this, right? So we have 2px, 2py, 2pz, right? So each orbital can have maximum 2 electrons. So I'll give you an example. For example, we have hydrogen with 1 electron, helium with 2 electron, then we have lithium with 3 electron, then beryllium with 4 electrons, boron with 5 electron, carbon with 6 electron, nitrogen with 7 electron, then oxygen with 8 electron, right? So if we start filling this according to the energy level, for hydrogen we will have this, right? For helium we have 2 electron. Now second electron, should we place it in 1s or in 2s, right? Since in 1s 2s there is a huge energy difference, so what is going to happen? The other electron is also going to fill in the 1s orbital, right? If we talk about the lithium, it has 3 electrons, so 2 electrons are already there in 1s. For the third electron we have to start filling 2s, okay? So it has 1s1 configuration, it has 1s2 configuration, this has 1s2 and 2s1 configuration. What about the beryllium? It has 4 electrons. So the fourth electron should go into the 2s orbital or in the 2p orbital. Since there is the energy gap, so that is why we will completely fill the 2s electron first. So beryllium will have a configuration of 1s2, 2s2, Now what about boron? Boron has 5 electrons. So 1s2, 2s2 and the next electron will move to the 2p orbital. So this is 1s2, 2s2 and 2p1. What about carbon? So the next electron will fill here rather than in the same orbital. Why? Because this is 2px, this is 2py, this is 2pz. So 2px, 2py, this is px, py, pz. These are degenerate orbitals. Okay, they have same energy. That is why they are going to fill all together one by one. Okay, it's not like we are going to fill px first completely. Why? Because px and py have the same energy. Whereas in case of 1s, 2s or 2p, they had this different energy, right? So in this case, in carbon case, it will be 1s2, 2s2, 2p2. What about nitrogen? So the next electron will come here. 1s2, 2s2, 2p3. Okay. Then in case of oxygen, next we have 3s. But again, there is the energy difference between 2p and 3s. That is why before we move to 3s, if there is any other electron, that is going to fill here in the p orbital. So that is why now we will have the configuration of 1s2, 2s2 and 2p4. This is what the Hund Rule of maximum multiplicity all about. It says if you have a degenerate orbital, that is the orbital having the same energy, then what we are going to do is we are going to fill them singly filled once, and then we will start the pairing of the electrons. Okay, so let me just write the complete statement first. It says pairing of electrons in the orbitals belonging to the same subshell. Subshell means S, P, D or F does not take place until each orbital belonging to that subshell has got one electron each. That means it is singly filled or singly occupied. Okay, so what does it mean? If we have p orbital, then first we will fill them singly, then only the pairing will start. In d orbital, we have 5 degenerate orbital, right? So first they will all fill singly and then the pairing will start taking place. And the ground for this is this, because of this they have because every electronic configuration, every atom want to achieve the minimum energy state. Okay, if there is any combination, energy combination or the electronic configuration possible where it can attain minimum energy, it will try to do that. And it has been found that they have the minimum energy when degenerate orbital, that is the orbital having the same energy, are singly filled first. If I do this for p orbital, if I do something like this, just a second, yeah, so if I fill something like this, that is for p orbital I have 3 electrons, then out of these two combinations, both three options are possible, right? Especially in case of nitrogen. In case of nitrogen, we have the configuration 1s2, 2s2, 2p3. So for the p orbital, we have 3 electrons. So we can arrange 3 electrons like this or like this, right? So out of these two combinations, it has been found that this has a lower energy as compared to this combination, right? So through the Hund's rule of maximum multiplicity, what we try to do is we try to achieve the minimum energy configuration. All right. So I hope you understood this whole concept. If you have any doubt regarding this, you can comment down below, or you can watch the previous video. Since this is a continuation of the other video, it is very helpful to watch the other video. Then you will be able to understand it completely. Okay, so with this we completed all the basic rule. In the next video we will talk about more configuration by combining all the knowledge, and after that we will talk about some exception, because chemistry is all about exception. There are certain exception and there is a reason also behind these exceptions. All right, so I'll see you in the next video. Thank you so much.